So now we get to start tying those two concepts together. So this idea of the x or the h and the k. And the key thing is that the vertex is the value of h. Oh, I don't like the red. Let me just go back to blue. So the value of the vertex is h, k. And the most important to remember is that the h value is the opposite sign of whatever's in here, right? So if you put a positive h value, it's going to appear negative. If you have what appears to be positive, it means you put in a negative h value, right? So think of this as solving a bracket. It's always the opposite sign. There's a rule in math transformations that anything on x is opposite as appears. Um, and there's multiple reasons for that. But if you can just remember that, you're good to go. And then the k is as it should be. So just pull off the k. And that the axis of symmetry will always be x is equal to h. So let's start with an example. We are going to graph y is equal to x minus 2 all squared plus 1. Can you pull out the vertex? Can you see that the vertex is going to be at 2, 1? And that means the axis of symmetry will be x is equal to 2. Now, up to you. You have two choices from here. You could graph that vertex at 2, 1, and then you could say, hey, I know what a parabola looks like. I can go over 1, up 1, over 2, up 4, over 3, up 9. And then I could do the same thing on the other side. Or if you don't trust it, what you're going to do is you're going to do a table of values. You're going to put the x equals 2 in here. Now you could even put 1 in here, or if you don't even trust that, you could then plug in that value of 2 and solve for y. You'd get 0 squared plus 1 is 1. Oh, look at that. My vertex is at 2, 1. And then you're just going to pick two x values up and down from there. So we'd pick 1 and 0 and 3 and 4. And what should happen is that we get 1, sorry, not 4. We're going to get that shape over 1, up 1, over 2, up 4, but from this vertex. Now, like I said, we've already done it. We could check what that point is. So we got that this point is 3, 2. Well, let's check it. So if I plug in x equals 3, okay, I'm going to get 3 minus 2 squared. Then I'm going to add 1. So 3 minus 2 is 1. 1 squared is 1. 1 plus 1 is 2. I have a point at 3, 2 from the vertex over 1, up 1. And I should get that symmetrical piece on the other side. If I plug in 1, I've got 1 minus 2 all squared plus 1. Gives me negative 1 squared, which is 1 plus 1 is 2. And then let's go one more out from there. So let's plug in x is 4. 4 minus 2 squared plus 1 is going to give me 2 squared. My 4s always look like 9s in Adobe for some reason. There we go. I get 2 squared, which is 4, plus 1 is 5. Let's check it. Over 1, up 1, 2, 3, 4 lands me at a point 4, 5. And that means it should be symmetrical on the other side. If I plug in x is 0, I end up with negative 2 squared is 4. 4 plus 1 is 5. I'm getting the shape I predicted. So I can plot those points. I can just map them to the other side or start from your vertex over 1, up 1, over 2, up 4, over 3, up 9, and then I can connect the dots. To graph a parabola, you want at least 5 points. I do as many as will fit on my grid. And then just not letting you forget what domain and range is. This would have a domain of negative infinity to infinity. And what would be the range for this graph? Well, it's going to start at y equals 1, and then it's going to reach up to infinity. Awesome. All right, so now you're moving on to the next part of your worksheet. So just combining left and rights and up and downs. Find your vertex, put that in the middle of your table of values or plot it, and then do your shape from there.